Think about the spell checker in your word processor. It's useful, it catches your typos, but the program still works perfectly fine without it. Now, imagine a program that isn't just checking your writing, but is writing with you, or even for you. A tool whose entire reason for existing is to generate ideas, craft paragraphs, and argue points. Without that intelligence, the application is just an empty box. This is the massive shift happening in technology right now. We're moving away from apps that are AI-powered and into a new era of apps that are AI-native. These aren't just tools with a clever feature bolted on. These are applications where the AI is the product, the very foundation. But to build this new kind of software, you can't just use the old blueprints. You need a completely new tech stack, a new set of tools designed for this new world. And understanding this stack is like getting a peek under the hood of the future itself, starting with the very ground these digital brains are built on. Every AI-native application, from a simple chatbot to a world-changing research tool, has to live somewhere. And in 2025, that home is unequivocally the cloud. The sheer amount of data and raw power needed is far beyond what anyone can keep in their office basement. This has led to a battle of the titans. In one corner, you have Amazon Web Services, or AWS, the established market leader. Their platform SageMaker is like an all-in-one Swiss Army knife for building, training, and deploying AI. In another corner is Google Cloud. This is the home turf of the company that literally wrote the book on much of modern AI. Their platform, Vertex AI, is a powerhouse, especially because it's deeply connected to their own cutting-edge AI models, like Gemini. And then there's Microsoft Azure, the enterprise giant. Their secret weapon is an exclusive partnership with OpenAI, the creators of GPT-4. This gives businesses a way to use the world's most famous AI models, but wrapped in the security and reliability that big corporations demand. Choosing one of these isn't just about picking a server. It's like choosing the operating system for your entire AI venture. But even with the right cloud, you need an engine, and not just any engine. You need specialized hardware, specifically GPUs, or graphics processing units. Think of them as supercharged processors on steroids. Companies like NVIDIA, with their A100 and H100 chips, build the undisputed engines of the AI world. Accessing these powerful chips through the cloud is the only practical way to get the horsepower needed to run a true AI brain. So you've got the real estate and the engine for your AI, but an engine is useless without fuel. And in the world of AI, the fuel is data. But this new generation of AI requires a special kind of library to store its knowledge, one that understands not just words, but meaning itself. This might be the single most important and least understood part of the modern AI stack. It's called a vector database. To understand why it's a game changer, think about how a normal database works. You search for a keyword, say Apple, and it finds every document that contains the word Apple. Simple. But it doesn't know if you mean the fruit or the tech company. It has no concept of meaning. A vector database is different. It's like a hyper-intelligent librarian. It doesn't just store words. It stores the meaning of your data as a series of numbers called an embedding. In this new kind of library, the concept of fruit is numerically close to banana and orange, while the concept of tech company is close to Microsoft and Google. So when you ask a question, the AI doesn't search for keywords. It searches for ideas. This is the magic behind a technique called Retrieval-Augmented Generation, or RAG. Here's how it works. You ask your AI a question about your company's latest sales report. The AI first goes to its vector database, this smart library, and asks, find me all the information that is semantically related to this question. The database pulls out the relevant charts, paragraphs, and numbers. Then the AI takes that retrieved information and uses it to form a perfect, fact-based answer. This is how you stop an AI from making things up or hallucinating. You ground it in reality, your reality. Companies like Pinecone, Weaviate, and Milvis are building these incredible databases that are becoming the unsung heroes of the AI revolution. They are the crucial link that makes a generalist AI feel like a specialist expert on your specific topic. Now that our AI has a foundation to live on and a specialized library to learn from, it's time to choose the most critical component of all, the brain itself. And this leads to the ultimate question every builder faces. Do you buy one off the shelf, or do you build your own?
At the heart of every AI native app is the large language model, or LLM. This is the core intelligence, the brain. And in 2025, you have three main paths to get one. The first path is the buy option. This is the fastest and easiest way to get started. You simply make a call over the internet to a model created by a major lab. The biggest names here are OpenAI with its famous GPT series and Anthropic with their powerful Claude 3 models. You pay for what you use, and in return, you get access to a state-of-the-art brain without any of the headaches of maintaining it. It's like hiring the world's smartest consultant on demand. The second path is the borrow option, which is a bit more hands-on. This involves taking a powerful open-source model and hosting it yourself. Meta's Llama 3 model completely changed the game here, offering performance that could rival the big proprietary players. Companies like Mistral AI from Europe are also releasing incredibly efficient and powerful open-source models. This path gives you more control, better privacy because your data never leaves your servers, and can be cheaper at a very large scale. The final path is the build option, or more commonly, fine-tuning. This is where you take one of those open source models and train it further on your own private data. This is how you create a true specialist. If you're building an AI lawyer, you fine-tune it on legal documents. If you're building an AI doctor, you fine-tune it on medical journals. This is done with frameworks like PyTorch and TensorFlow, the fundamental building blocks for AI researchers. Choosing your brain is the most defining decision you'll make. But a brain, even a brilliant one with a perfect memory, is useless if it can't be told what to do. It needs a nervous system to connect it to the world and coordinate its actions.
So you have a brain and you have a library of knowledge. Now, how do you get them to work together to accomplish a complex task? What if you need the AI to first search the web, then look up something in your vector database, then analyze the results, and finally write an email summarizing its findings? This requires a chain of actions, an orchestration, and that's where LLM application frameworks come in. They act as the nervous system for your AI. The most popular one is called LangChain. Think of it as a toolkit full of pre-built connectors and logical quote chains. It gives developers a way to easily tell the AI, first do this, then, based on that result, do that. It helps manage the entire, often complex workflow of an AI native application, abstracting away the tedious parts. Another major player is Llama Index. While LangChain is a general-purpose project manager, Llama Index is a specialist, laser-focused on building those Retrieval-Augmented Generation, or RAG, applications we talked about earlier. It's the master of connecting your AI brain to your custom knowledge base, making it incredibly good at data ingestion and querying. These frameworks are almost always written in Python, the undisputed language of AI, and they are often served up through a modern backend tool like FastAPI, which is built for the kind of high-speed, responsive communication that AI applications demand. This nervous system brings the AI to life, allowing it to execute sophisticated, multi-step tasks. But like any complex system, especially one that is learning and evolving, it can get sick. It can behave in ways you don't expect. And that's why you need an immune system. An AI native app isn't a piece of software you finish and walk away from. It's a living system, and like any living system, it needs to be monitored. This is the domain of a new field called LLMOps, or machine learning operations for large language models. What are you monitoring for? First, you're watching for drift. This is when the real-world data coming into your app starts to look different from the data the AI was trained on, causing its performance to degrade over time. Second, and most importantly, you're monitoring for quality and hallucinations. Is the AI giving helpful answers, or is it going off the rails? Is it being evasive? Is it suddenly costing you a fortune in API calls? You need to know, and you need to know why. This is where a new class of observability tools comes in. Platforms like Arise AI and Y Labs act like a doctor for your AI, constantly checking its vital signs in production. But perhaps the most interesting tool is LangSmith. It's built by the same people who made LangChain, and it gives you an X-ray view into your AI's thought process. If your chatbot gives a weird answer, LangSmith lets you trace back every single step it took, which tool it used, what data it retrieved, and which prompt led to the final output. It's like a flight data recorder for your AI. Without this immune system, you're flying blind. You have a powerful, intelligent system running in the wild with no way to diagnose or fix it when it inevitably goes wrong. This layer turns AI from a cool experiment into a reliable, enterprise-grade product. So we have the foundation, the brain, the knowledge, the nervous system, and the immune system. Now, let's see how it all comes together to build two very different visions of the future. Let's make this real. Imagine a lean startup trying to build the next big thing, a customer support chatbot that knows their product inside and out. What does their stack look like? They'd likely use a model API like Anthropic's Claude to avoid infrastructure costs. For their smart library, they'd use a managed vector database like Pinecone because it's fast and easy to set up.
they'd use LangChain to wire everything together and host their application on a serverless platform like Vercel. For the user interface, they would use Vercel's AI SDK to quickly build a slick streaming chat experience. Their stack is built for one thing: speed. Now let's imagine a huge financial firm building a powerful internal tool for its analyst. Their needs are completely different: control, security, and massive scale. They would likely take an open source model like Llama 3 and fine-tune it on decades of their private financial data. They'd host this model on their own dedicated cloud infrastructure in AWS or Google Cloud. For their data, they'd use an industrial-strength platform like Databricks for processing and a highly scalable vector database like Milvus. Their orchestration would be more robust, and their MLOps and monitoring would be a top priority, using tools like Arise AI to ensure accuracy and compliance. Their stack is built for one thing: power. These two blueprints show that there isn't one single best stack, it's a set of building blocks. The choices you make at each layer, from the foundation to the face of the application, determine what you can build.
The rise of AI-native applications is more than just a trend. It's the beginning of a new era in how we create and interact with software. The stack is no longer just a database, a backend, and a front-end. It's a living architecture composed of a cloud foundation, a knowledge base that understands meaning, an intelligent brain, a nervous system to coordinate it, and an immune system to keep it healthy. Understanding these layers isn't just for developers or CTOs, it's for anyone who wants to understand the world that is currently being built all around us. Because the applications that will define the next decade won't just use AI as a feature, they will be born from it. And they are being assembled piece by piece right now. If you found this video helpful, a subscription to the channel is always appreciated. Thanks for watching.